Regression Analysis by Jonathan Rosenthal, MBA, American Society of Clinical Oncology, Department of Clinical Affairs. I'm a graduate student at George Mason University's Department of Health Administration and Policy, HAP823, Causal Analysis and Comparative Effectiveness, and my professor is Dr. Alemi. This presentation was prepared as part of HAP823 course on competitive effectiveness taught by Farrokh Alemi, PhD at George Mason University, Department of Health Administration and Policy. I am a healthcare report specialist on the Quality Oncology Practice Initiative team within the Department of Clinical Affairs at the American Society of Clinical Oncology. I manage the federal compliance for 2 registries, the Standard Registry and a QCDR, as well as their associated informatics. My professional background includes 5 years of cancer research, 4 years of software development, and over 10 years of pharmaceutical consulting specializing in cytotoxics. I am a PhD candidate at George Mason University Department of Health Administration Policy with a concentration in health informatics. I have an MBA from Fairleigh Dickinson University with a concentration in health sector management. When I am not working or when I am typically in school, I am with my wife and my 2 daughters, and I enjoy staying active. In this particular assignment, we were given data in 2 different formats, 2003 and 2010 XML. We'll be looking at the drug CIT, and this data comes from the STAR-D experiment conducted by the NIH. As I present this data to you, I'm going to show you that I manipulated the data in both the free software R as well as using SAS, the proprietary software that is most highly used in business. So what is logistical regression? Logistical regression in statistics is the method for analyzing a data set that has more than one independent variable that determines an outcome. Within our assignment, there are several CIT related outcomes, for example, combination therapy as noted below. What you see on screen now is one of the mirror sites for downloading R, which is free. And this is typically what's used by students. It's command line code, very simple to if you are using Unix or DOS. Once you install the software, here are the following procedures for manipulating the data and setting the fields. This is very important. So first you have to identify the data. You have to, in number 2, is extremely important because when working with these data sets, the first thing you may need to do is if there's large chunks of data that have no information, there's nothing binary, you have to omit that data or at least change that data set. Very important in this process. You have to review your column names to see what the data set you're working with, and what you want to do is try to limit the set as small as possible so that the crunching time and the possibility of system crashes is diminished. You select the set of variables that you want to construct your logistic regression on to predict this model for the success of CIT. And I've documented it here in steps 4, steps 5 where you're binding, and then in step 6 where you're actually looking at the dimensions. Proceeding further, we're looking at step 7 where you create more regression analysis column, and you're calling it my model, where GLM in this code stands for generalized linear models. Formatting the data is another important step after you move past this step. And finally, here's a summary of the data set, and I will also be showing this in SAS later on. Here are the column names that you want to work with. You want to cut those column names down. Here's another sample set, and you see we're going down from 42 down to 12 columns to be used. We're doing the binding, or in some cases you might need, if you stripped one out and you realize that you need to put it back in, you need to do a bind. And you can see this in the code as E equals C bind E, and then D22, which identifies the 22nd column from the original data set. Here's the output. You can see those data sets. It's the same thing that you saw on the previous screen, just larger. An example here is the patient IDs because it is so complicated, you want to remove this type of field because it'll complicate the data, and it caused me, as I was doing this assignment, to crash twice. The regression analysis here are the products, and you can see zero significance, almost a one-to-one relationship all the way through all the different modalities. Here I've fixed the data in place. Here's an example of the scatter plot. And now I'm going to be showing you how to do the same functionality in SAS. And SAS is the proprietary software that most of business use in statistics. Identify the data set. Import the data set. You can see it here. I've named my work John. And you can see the same data set. No longer is it being seen in Excel. It's being seen in SAS. And here you can see the procedure codes, the SAS code that I wrote to get the same summary information that was presented earlier in R. And we can see these data summary SAS results, male, female, frequency, percent, cumulative frequencies, all across. I've divided everything down by race, unspecified, included. Again, here's another way of looking at the same information with the procedure codes. And more examples of looking at the variables. These are all standard functionalities that with a summary output right from SAS. So it's much easier to do in SAS versus R. I hope you enjoyed my presentation.